Welcome to the fundamental concepts. Today we are dealing with an important concept called the calculus. Calculus is called the fundamental concept because it laid the foundation stone for further progress of science. Until unless the calculus is invented, the contribution of science is very slow. But after being used, the invention of calculus, it has been used in every field. Today, it surpasses every field and it has been an important tool for finding various concepts and various methods to find what is unknown. Without the calculus, I think today what we are seeing is impossible. So first of all, we'll understand what is the concept lying behind calculus. It has been started in 17th century by Sir Isaac Newton as well as along with Leibniz parallelly. So before going into the history or going into the deep topic, we will first understand what is a function and how it is related to calculus. Before going into functions, let us try some example and explain what are functions. So here, let us find an example. Let us consider a circle. Okay, circle. So this circle is having a radius r. Okay. Now, you know what is the area of circle? Area of circle is equal to pi into r square. That means A is equal to pi r square. Is it? Here we see that r is represented by radius. It means whenever r is equal to, that means capital R is equal to 0 or 1 or 2 or 3 or 4, whatever it is, A is also having corresponding values regarding this. Suppose when r is equal to 0, A is equal to 0 because r0 is 0. So no, when r is equal to 1, that is equal to pi. Pi into 1 square is equal to pi. Similarly, for different values of r, we have different values of A. That means when r is taking values from 0 to up to infinity, right? So then A is also having corresponding 0 to corresponding infinity. That means r is here independent variable. And A is a dependent variable. Right? That means depending on r, we have value of A. That means both are related to each other. That means A is depending on r. That means simply we can say A is function of r. F represents function. Right? That means simplifiedly you can write A is function of r. That means this function again, function distributes like this. Function is here by r square. Means A is equal to like this. In short form, you can write, we have to tell, when you are telling dependency of A with respect to r, you can write in this format, that is A is the function of r. Right? Similarly, that means that when you are generalizing this, when you want to generalize this, it means suppose we take y as one variable, r as other variable, x as other variable. Okay. Similarly, like A is function of r, we can write in terms of y is A can represent by y and r by x. That means this equation tells that y is dependent on x, that is y is function of x. In this case, area of circle f function is equal to by r square, or we can write y is equal to what, how much, pi into a variable is r here for radius, but here we are substituting with x, right? It is x square. That means suppose there is a circle and this is x, then a is equal to, or y, we are writing a with respect to equal to y equal to x by x square, right? That means in general y is equal to f of x. This is a representation of a function. So we can take one more example. Suppose y is equal to x square, right? That means for x is equal to some values like 0, 1, 2, 3, 4, like that. What will be y? Y is equal to how much? 0 first. Next is when substitute 1 here becomes 1. 2 it is 4, it is 3, it is 9, it is 6. That means you can write a table like this. This is x and this is y. So for 0 this is 0, for 1 this is 1, for 2 it is 4, for y is equal to x square I am saying, for 3 it is 9, like that. That means y is a dependent variable on x and x is independent. That means you can take any value from 0 to infinity. So you can say this is a y is a function of x, but here the function is x square. Function is x square, right? So this is how we talk about functions. You can say in graphical format. So this is one axis and this is other axis x. This is y axis. That means all y values comes in this way and all x values will come in this direction. So for y is equal to x, you can generally write like this. Generally we can show like this a diagram. That means for every value of x here, we have a value on y axis, that is y. For x1 we have y1 and for x2 we have corresponding y2. That means they are related. So for y is equal to x square, how it will be? See, this is the diagram. This is y is equal to x square, and this is 0, and this is 1. This is x-axis, positive x-axis, this is positive y, positive x, and this is negative x, and this is negative y. So for every value of x, suppose y is equal to 1, this is 1. Suppose this is 2 for that, this is y, 2, this will be 4 on y. Similarly, if you are writing for x is equal to 3, we have y is equal to 9. So this is how we are representing a function in a graphical format. So now we will take one function, a general function. Y is equal to f of x. Okay, this is a generalized function which is defined in certain interval. Okay, so for each value of x there is a unique corresponding value of y in this interval, then only this is function defined, right? That means for every value, that means you can say interval can be like from infinity to plus infinity to minus infinity. It can be anything. So when you are defining a when you're taking x from this interval, y is also having some different value corresponding to this x depending on the value of function. So suppose if it is x square, it is definitely like suppose x is equal to 1, that is y is equal to 1. If x is equal to 2, then y is equal to 4 depending on, because x is here, function is x square. Suppose function is equal to x cube, if you imagine, then for 1 y will be 1, x is equal to 1 y. Suppose x is equal to 2, y is equal to 8. So depending on the value of function, we have a different value for y. So now what we are saying is, in this when you are generalizing this function, let the value x takes an increment, small increment. Delta x, we say delta x means very small value. That means suppose, so for the small increment there will be some small changes even in y. So that means, so for small increment in x, we have a increment, corresponding increment in y, that is corresponds to y plus delta y will be f function of this delta x. So suppose you want to know what is increment. So increment in the function, function is equal to how much? Definitely delta y. This is a change, right? How we will write? This is delta y plus minus y. So this is equal to f of x plus delta from here, and from y is equal to minus x. That means increment in y is equal to this much, right? Now this increment we have got is delta y. This is some equation is f of x plus delta x minus f of x, right? So if we compare, if we compare this increment in y, that is delta y with respect to delta x, what it will become? That is delta y divided by delta x is equal to f of x minus f of x divided by delta x. This is the ratio of these increments with respect to independent variable as well as dependent variable. Now if this delta x is approaching smaller values, approaching 0, if you assume, like that means from 0.01, next 0.0001, next it is 0.00005, like that. When the value of delta x is decreasing, what happens? It means that when this is approaching towards 0, that means see here these are coming towards 0, but still they have some value. Then this ratio is termed to be approaching a limit. Okay. For example, we have two ratios like 4 by 5. Okay. What is the value of 4 by 5? You know it is 0.8. Okay. Suppose we don't change 4. Now denominators will take plus 0.01 and we take 0.001. That means change I am saying. If this change, what is the change here? 0.1. Okay. of the chain. That means what this is what how much. Here in this example, 4 by 5. This is y and this is x. Okay. Now 4 by 5 plus 0 1. This delta x is equal to 0 1, right? Now this is approaching 0. That means the delta x can be like 0.001 or it can be 0.00001. So it is approaching towards 0. Then what is this value of this ratio? So we got here Lego 4 by, this is first ratio. When this delta x is reduced to 0.001 or this small 0, this is again 0.77. That means it's nearing, this is approaching towards 8. But again, if you are still reducing, it is still near to 8. That means 8 is the limit of this fraction or this ratio. Okay, this is how we are defining. So the generalized equation, when this ratio when delta x is approaching 0, this ratio will approach some limit that is called as, defined as f dash x. Okay, this is called f dash x. So it is sometimes called as derivative of the function y. That means we are saying y is equal to f dash x is the derivative of y when the ratio, when delta and the denominator is approaching 0, then the ratio approaches a limit called derivative of that function. So now this is represented as f dash x. This hyphen is called prime or f dash x, and this LT is the limit delta when for this delta y by delta x is equal to f plus this is x, sorry, minus f of x divided by delta x. So this is the derivative of the function. You have to understand what actually this means in a geometrical way. So we will explore that also. So next we will see the geometrical meaning or geometrical understanding of derivative. This is called geometrical meaning. So let us consider a function like in a graph. Let us see. Sorry. Let us consider a function y is equal to f of x in a graphical form. So this is y is equal to f of x. It can be any form. So this graph can be any way. It can be like this or any curve, because this is a generalized version. A coordinate x is x and y, and for every x there is a y for the other curve. It is defined as a defined in a defined interval. This is the function is defined. So now for certain value of x here, we have certain value of y, and this point we are taking as m0. Okay. Now let us increase the value of x by delta x. Okay. Now we take one more value here somewhere which is corresponding to delta x, that is x plus delta x. This is x plus delta x, and corresponding y will be y plus delta y. Okay, these are coordinates of this point. This is m1, and now let us draw a line connecting these 2 points. Now when you draw a line connecting these two m1, m0 and m1, this again when extending up to the x-axis, this meets at point S. This is called as m1. This line is called as secant line, because this is connecting m0 and m on a curve. Secant is a different secant line. This is making an angle called phi. So if we take tan phi in this triangle, so this is forming a triangle, right? M1, S, and this point, suppose it can be like S dash something. What happens? Tan phi is equal to this, and that is equal to how much? Yeah, we take in this small triangle. Now we take the small triangle, where this phi is all this phi are same because these two lines are parallel and these are alternative angles. So in this triangle, we take tan theta, that is equal to tan theta. This is again delta y, because this is up to here it is y, and this is up to here it is y plus delta y. So this will be like delta y. Tan phi is equal to delta y, and this value is delta x. So this tan phi is equal to delta y by delta x. At this stage, suppose we imagine that the value of delta x is approaching 0. That means the value approaching 0, that means this is reducing, this value is going back, and this will be coming back. This will be coming back, or this point m will be sliding backwards. That what happens then, this m1 will be moving along the curve towards m0 like this, and finally it will merge with m1. When x approaches 0, the point m1, that is whatever is there, is approaching towards m0. Okay, that means the line, secant line, if we say it is m0, m0 m1 will become a point m0 when this is approaching towards 0. So during this stage, we see that when this delta x is approaching 0, this m1 point from here, it will travel towards m0. That means this is reducing, the space is reducing, and when what happens, delta x plus delta, when this is becoming 0, this becomes x. That means it will finally merge with this point. That means what happens to tan phi? Tan phi is equal to delta y by delta x. In this condition, when delta x is going to 0, this ratio will approach a limit at m0, right? So that is corresponding value will be tan alpha, right? But this is called tangent line at point m0. So that means that the derivative of the function y is equal to f of x on a curve approaches tangent line at the point defined. So f of x is equal to this tan alpha, implies that when this tan phi reverse is equal to 0. So you imagine this is traveling like this and approaches this point. So finally this is tan alpha is a tangent at point m0. This is the geometrical interpretation of the derivative at a point. So we will see some example how we'll understand this. For example, we take function. Let us take a function y is equal to x power n. So what is the derivative of this? of this function. How we will do? So as for derivative function, we know that if x takes an increment delta x, then y becomes incremental form delta y, that is equal to x plus delta x whole power n. Right. Now the increment is equal to delta y is equal to y plus delta y minus y. Right. So we know this is delta y, that is x plus delta x whole power n minus y is equal to x power n. So this term we have to expand. For expanding this term, we use binomial theorem. X with respect to binomial theorem, that is equal to x power n, first term, next again n into factorial 1 into x n power minus 1 into delta x whole power 1. This is the first term. Next term will be n into so here it is n into n minus 1. This is the next term, divided by 2 factorial into this will become x n minus 2 into this becomes square delta x whole power n, so on forth. Last it will remain is, no, this is x delta x power n, because here delta x is 0, only x power n. Similarly, the last term will be x will be 0 and x power n will be the whole term. So this is how we write. So in this we substitute minus, this is what the expansion of this term, this one term, right? Now from the formula, so from this equation delta y will be y plus delta y minus y, that is equal to, we have seen this, x power n by n factorial to delta x plus and so forth whole power n minus x power n, right? This will cancel out, so we are remaining with x n into n plus minus delta x power 1 plus the next term is n to n minus 1 by 2 factorial into x into n minus 2 into delta x, sorry, so here we have expanded this term with the cancelling this one. So now the delta y, the ratio delta with respect is equal to n into x power n minus 1 into delta x, and we divide this delta x. Next term also we will divide 2 factorial to x power n minus 2 into delta x whole square divided by delta x, and so on so forth, delta x by power n. Okay. So here this will be cancelled out. This becomes 1 here and this becomes n minus 1. So we are left with n into n over whole power 1. There is no delta x here, and next term will be n into n minus 1 2 factorial into delta n 2 into delta x until this is delta x n minus 1. So when this, the ratio delta y by delta x, when x is turned towards 0. That means it is smaller and smaller. This term here, this will be 0 and this will be 0. That means the whole term will be 0. So we are left with only n here because there is no delta x in this term. We are left with x minus 1. That means when delta y by delta x is approaching 0, this will approach n into n minus 1. That is limit, which is y dash. So derivative of this function will be n into n minus 1. So this is how we will derive that formula. So we'll use some example here. Suppose y is equal to x power 5, right? So here y, which is in the format of x is y is equal to, suppose we take a function y is equal to x power 5. So this is in the format like y is equal to x power n, right? Here n is equal to 5. So what is the derivative of this? That is, you know, is n into 4n minus 1, right? So here n is equal to 5 into x into 5 minus 1, that is equal to 5 into x power 4. So this is how derivative of x power 5 is 5x power 4. Suppose we write one more equation like y is equal to x. So what is its derivative? It means here y is equal to x power 1. So we know that when it's 1 is n into minus 1 y dash. Using this we'll get 1 into x into 1 minus 1, that is equal to 1 into 0, that is equal to 1 into 1 equal to 1. So y dash of is equal to 1 of the constant, and there is no power here. 1, y is equal to, derivative is equal to 1.